Hello, so in this video we are going to do a question on gravitational field on 2-point masses. So this question says that a kilogram mass rests on the surface of the earth as shown in figure 1.1. A spherical rock S whose center of mass is underneath the earth's surface at a distance d of 3.5 kilometer has radius of 2 kilometer. The density of the rock is 2,500 kilogram per meter cube. So from this question we can say that the distance from here to the center of this rock is 3.5 kilometer, and the radius of also this rock is 2 kilometer. And also the density is 2,500 kilogram per meter cube. Determine the force exerted on the kilogram mass by the rock S, justifying an approximation. So they say they need the approximation because the question have not stated the radius of this rock. So how would we calculate the force exerted on this kilogram without knowing its radius? So we will just approximate. So first of all, we have to let's write the given. So we have the radius of course it's for the rock S. Okay, so the radius R is 2 kilometer. We have to change it to meter, and that's gonna be 2 times 10 cube meter. And D is the distance, it's 3.5 because we have to change it to the meter. This thing we will use it when we calculate force. Okay, and also we have the density, and it's 2,500 kilogram per meter cube. From this information we can get the mass of the rock. So we can get the mass of the rock. We have the density for formula, which is mass over volume, and the volume it is 4/3 pi r cube. So the mass is equals to density times volume. So first of all, let's calculate the volume, and the volume is 4/3 times pi times the radius of this rock, of the bigger rock, of the rock S. So it is going to be 2 times 10 cube. Okay, so let's calculate this one using our calculator. We forgot something, we did not cube this thing, so we'll cube it, and it's gonna give us 3.35 times 10 to the power of 10. Okay, so let's just find the mass. So the density is 2,500 kilogram over meter cube times this one, the volume. So this will be cancelled by this, and kilogram is left. So let's multiply 2500 by 3.35 to the power of 10 times 10 to the power of 10. So the mass is 8.37. Let's say that 8 times 10 to the power of 13. Now, and also here we have the small m, which is 1 kilogram, and we got the big M, and it's 8.378 times 10, 13. So now we can find the force exerted on these two objects, and we know the formula, that is G, capital or big G, multiply by the masses times the distance between those masses. The big G is 6.67 times 10 to the power of 11. Let me make my handwriting smaller. Times the mass of the spherical rock times the 1 kilogram mass. Just not necessary to write the 1 kilogram over. So this one, it's supposed to be the distance from the center of this rock to the center, to here, but we don't have the center of the radius, and that's why they say they need the approximate force. So we will just calculate the D, that is from here, that is from here to here, that is 3.5 kilometer, that's 10 square. So we will just use our calculator. So our answer is 4.557 times 10 to the power of -4 newtons. So let's just recall what we did. The question asked us the force exerted on the 1 kilogram by the spherical rock, and they gave us the radius of the spherical rock and the distance of the surface of the rock, of the mass, and also from the surface of the mass to the center of the rock, which is 3.5 kilometers. And also they gave us the density of that rock, the spherical rock, and we used that to calculate its mass. And after that, after we got the mass of the spherical rock, we used the formula of the Newton's gravitational law, and that's how we got the force.